Hey everyone, welcome to Theta Math. Today we're exploring one of the core ideas in trigonometry, addition and subtraction identities, just like this one, the cosine subtraction identity. Cosine A minus B equals cosine A times cosine B plus sine A times sine B. We'll break it down and actually prove it using just a unit circle and the distance formula. No memorization, just understanding. By the end, you will really understand where these identities come from. Let's get started. First, when you look at this formula, you want to solve cosine for an angle of A minus B. Then the first thing you could probably do is construct an angle like A minus B. So we can first draw an angle here called A. We can put the start as called P and the origin as O. Then, because we want A minus B, we can draw another angle, like here, called B. This point called Q. Then right here, you will get an angle A minus B. But how do you find the cosine of this angle? You have to have one side of the angle to be on the positive x-axis, just like angle A and B, in order to solve for its cosine. So we can actually right here connect PQ and then simply rotate it to make OQ touch the x-axis, just like on the second one. We can write this as P prime, O, and Q prime. We rotated this triangle. Now, if we connect P prime, Q prime, then this angle, P prime, O, Q prime, is equal to A minus B also. Now, we can see clearly because we rotated it, so these two triangles, POQ and P prime, O, Q prime, are actually congruent. So PQ is actually equal to P prime, Q prime. Next, because we want to use this, let's see how it does with cosine and sine. How can we put the trig identities into these? You can notice really quickly, if we start labeling some coordinates, then you can find that the coordinate of Q, because this is on the unit circle, then we can actually count this as cosine B and sine B. Similarly, the coordinate of P, cosine A and sine A. Similarly, on this graph, the coordinate of P prime then will be cosine A minus B sine A minus B. And the coordinate of Q prime will be 1, 0. Now, you actually see the cosine A minus B. And you see other components like cosine A, sine A, cosine B, and sine B. So by calculating the distance of PQ and P prime Q prime and constructing an equation, we can actually solve for this. So let's start. PQ equals the square root of cosine A minus cosine B squared plus sine A minus sine B squared. Let's expand this. Equals the square root of, this is going to be a long one, cosine squared A minus 2 cosine A cosine B plus cosine squared B plus sine squared A minus 2 sine A sine B plus sine squared B. Now, this is very long, right? You can look at these square terms, cosine squared A, cosine squared B, sine squared A, and sine squared B. And you can remember that sine squared theta plus cosine squared theta actually just equals 1. Really easy, right? So you can see here, you have two pairs, sine squared A plus cosine squared A, sine squared B plus cosine squared B. And this equals, because there are two pairs, so you have 2. This equals 2 minus 2 cosine A cosine B minus 2 sine A sine B. We're pretty much done for this one. So let's see P prime and Q prime. What does that equal to? Look up here for the coordinates. We can see that P prime equals cosine A minus B minus 1 whole thing squared plus sine A minus B minus 0 squared. But because it's minus 0, we can just don't care about this and just write sine AB squared. Now, this, we expand this, we can write it as cosine squared A minus B minus 2 cosine A minus B plus 1 plus sine squared A minus B. Now, seeing the formula right here, and we can find that sine squared A plus B plus cosine squared A plus B is also equal to 1. The theta here not only just represents an angle, a number, or a constant, or a variable, it can also represent an expression. So here, you can get equals to 2 minus 2 cosine A minus B. Pretty neat, huh? So now, for the final one, because PQ equals P prime Q prime, we can construct an equation. PQ equals P prime Q prime equals the square root of 2 minus 2 cosine A times cosine B minus 2 sine A times sine B. And this equals P prime Q prime, which equals just the square root of 2 minus 2 cosine A minus B. Now, because these are both square roots, we don't want them. We can actually square both sides of this equation. So which makes 2 minus 2 cosine A cosine B minus 2 sine A sine B equal to 2 minus 2 cosine A minus B. This is very similar to the original identity. Now we can subtract 2 on both sides. We don't want them. And then it will be negative 2 cosine A times cosine B minus 2 sine A times sine B equals negative 2 times cosine A minus B. It's the last step. And we can just divide negative 2 on both sides. Pretty easy, huh? And we rotate it to make it cosine A minus B equals cosine A times cosine B. Very careful because you divide by negative, plus sine A times sine B. And voila, that's how you get the first formula. So we already found that cosine A minus B equals cosine A times cosine B plus sine A times sine B. But actually, there's so many other, there are actually in total 6 of these functions. How do we solve either of them? So for cosine A plus B, it's just equivalent to cosine times A minus negative B. You plug in negative B as B. And for sine, you can use the cofunction identity. Cosine theta equals sine 90 minus theta. You can use this and plug in this into all of these. And similarly, for tangent, it's the most fun part, that you actually can do sine theta over cosine theta just equals tangent theta. So similarly, sine A minus B over cosine A minus B just equals tangent A minus B. So as a challenge, you can try on your own to prove the rest of these formulas. Let me know if you have any questions in the comment section. And that wraps up the proof. No memorizing, just logic and the unit circle. If you found this helpful, drop a like, maybe sub, and I'll see you in the next Theta Math video.